Hello guys, welcome to Makaut Smashers and also welcome today. We will delving into the fascinating world of soft computing in computer science. Soft computing is an innovative approach to solving the complex problems by mimicking the human reasoning and decision making. We will explore the key components like fuzzy logic, neural network, genetic algorithm and see how they power everything from AI to autonomous vehicles. Whether you are a student, professional or tech enthusiast, this video will give you a deeper understanding of how soft computing is shaping our future. Let's get started. So at first, the introduction to soft computing. Soft computing is a collection of computational techniques inspired by the biological processes that are designed to model and solve the complex real-world problems characterized by the uncertainty, imprecision, approximation. Unlike traditional hard computing, which relies on binary logic and crisp value, soft computing encompasses the methodologies such as fuzzy logic, neural network and genetic algorithm and probabilistic reasoning. These techniques allow for more flexible and tolerant problem-solving approaches, mirroring the human decision-making process. The importance of soft computing lies in its ability to handle the ambiguity and partial truths inherent in many practical scenarios, making it invaluable across various fields. In engineering, it enhances the design and the optimization of complex systems. In finance, it improves the risk assessment and algorithmic trading. In healthcare, it benefits through enhanced diagnostic tools and personalized treatment plans. Additionally, soft computing finds the application in robotics, data mining and natural language processing, demonstrating its versatility and significance in advancing technology and improving the quality of solutions in diverse domains. So now it is time to discuss about the components of soft computing. Okay. So soft computing is a paradigm that aims to exploit the tolerance of imprecision and uncertainty to achieve the tractability and robustness and low solution cost. It is inspired by the human's mind's capability to process ambiguous and imprecise information effectively. So the core concept revolves around building systems that can adapt and learn in dynamic environments, mimicking the natural processes. The main components of soft computing include the fuzzy logic, the neural network, genetic algorithm and evolutionary computation. So fuzzy logic deals with the reasoning that is approximate rather than fixed and exact, enabling the model of complex system with a high degree of uncertainty. Neural network, inspired by our human brain's network of neurons, are computational models that are capable of learning from the adapting to data, making them powerful tools for pattern recognition and classification tasks. Genetic algorithm are optimization technique based on the principle of natural selection and genetics, providing the robust solution to complex optimization problems by evolving the solutions over generations. Evolutionary computation, a broader term that includes the genetic algorithm. It encompasses a range of algorithms inspired by the biological evolution. It focuses on the iterative improvements of candidate solution. Together, these components form the foundation of soft computing. It enabling the development of intelligent systems capable of solving the real-world problems with the high complexity and uncertainty. So now it is time to discuss about the fuzzy logic. So fuzzy logic is a form of logic that allows for reasoning with degrees of truth rather than the traditional binary true or false value. It is designed to handle the also the concept of partial truth, where the truth value may range from the completely true and completely false, means 0 to 1. This flexibility and makes the fuzzy logic particularly significant in managing the uncertainty and imprecision, as it more closely resembles the human reasoning and decision making process. So unlike the classical logic, which requires the rigid boundaries, fuzzy logic operates with fuzzy sets and membership function, allowing for smooth transitions and more interpretation of data. Okay, so fuzzy logic's ability to handle the uncertainty and imprecision has led to its widespread application in various fields. In control system, fuzzy logic controllers are used to manage the complex processes where precise mathematical models are difficult to obtain, such as in automated washing machines, where it adjusts the washing cycles based on the load size and dirt level. In image processing, fuzzy logic enhances the image contrast, the edge detection and segmentation by dealing with inherent in pixel intensity value. In decision making system, the fuzzy logic aids in scenarios where the decisions must be made based on ambiguous or incomplete information, such as medical diagnosis system where it helps in evaluating the symptoms that do not have clear-cut boundaries. So these examples illustrate how fuzzy logic contributes to more robust and adaptive solution in environments fraught with uncertainty and imprecision. So now it is time to discuss about the neural networks. So neural networks are the computational models inspired by the structure and function of human brain, consisting of interconnected units called neurons. These artificial neurons, arranged in layers, process the information in a way that mimics the brain's neural network. Each neuron receives input, applies a weight to it, and processes it through an activation function, and passes the output to the next layer of the neurons. So this architecture enables the neural networks to learn from the data through a process called training, where the neural network adjusts its weights based on the error in its predictions, gradually improving its accuracy. So resemblance to the human brain lies in the network's ability to recognize the pattern, make decisions, and adapt to new information. Neural networks can learn from the large amount of data, identifying the complex relationship and correlation that are difficult to model with traditional algorithms. So neural networks have a range of applications due to the powerful pattern recognition capabilities. In image recognition, the neural network, particularly the convolution neural networks, are used CNN to identify the objects, faces, and scenes, making them essential in fields like security, healthcare, and social media. In speech recognition, the neural networks enable the virtual assistants like Siri and Alexa to understand and respond to the human speech, facilitating the seamless human-computer interaction. Autonomous vehicles rely on neural networks for real-time processing of sensor data, helping them navigate, recognize the obstacles, and make driving decisions. These examples highlight how neural networks transform the various industries by providing the sophisticated, adaptive, and efficient solutions to complex problems. So now it is time to discuss about the genetic algorithm. So genetic algorithms are the optimization technique. It is inspired by the principles of natural selection and genetics. These algorithms solve the complex problems by mimicking the evolutionary process, where the fittest individuals are selected for reproduction to produce the next generation. So genetic algorithms operate on a population of potential solutions, applying the genetic operators such as selection, crossover, and mutation to evolve the solution over successive generation. The fitness of each individual in the population is evaluated based on the predefined objective function, and the best performing individuals are more likely to be chosen for reproduction. So the process begins with a randomly generated population of solutions. Selection favors individuals with higher fitness scores, ensuring that desirable traits are passed on to offspring. Crossover or recombination combines the parts of two parent solutions to create the new offsprings, and introducing the variation and promoting the exploration of the solution space. Mutation introduces the random changes to individuals, ensuring the genetic diversity and preventing the premature convergence to local optima. Over time, the population evolves toward increasingly optimum solutions, effectively solving the optimization problem. So, genetic algorithms have numerous applications across the various fields. In scheduling, they optimize the complex timetables and resource allocation, such as airline crew scheduling, where multiple constraints and preferences must be balanced. In design, genetic algorithms aid to the certain of innovative and efficient designs, such as optimizing the aerodynamic shape of vehicles or layout of electronic circuits. In AI, the genetic algorithms are used to evolve the neural networks and optimizing their architecture and weights to improve their performance in tasks like game playing and robotics. So these examples demonstrate the versatility and effectiveness of genetic algorithms. It is taking the challenging optimization problems by harness the principles of natural selection and genetics. So now it is time to discuss about the evolutionary computation. It is a subset of AI that uses the mechanism inspired by the biological evolution such as reproduction, mutation, recombination and selection to solve the complex problems. This approach encompasses a variety of algorithms including the genetic algorithm, genetic programming and evolution strategies and differential evolution, all of which use the population of solutions that evolve over time to improve their performance with respect to given objective function. So the role of evolutionary computation in adaptive system and optimization is significant due to its ability to adaptively search for optimal or near optimal solution in large, complex and dynamic search space. Evolutionary algorithms are particularly well suited for problems where the solution landscape is rugged and with many local optima, and or where the problem parameters change over time. So by continuously evolving and adapting, this algorithm can effectively navigate such challenging environments, finding the high quality solutions where the traditional methods may struggle. Applications of evolutionary computations are diverse and impactful. In robotics, evolutionary algorithms are used to develop the adaptive control system and optimize robot behavior, enabling the robots to learn and adapt the new task and environment automatically. In game theory, the evolutionary computation helps in designing the strategies and evolving the competitive behaviors in multi-agent system, enhancing the performance and robustness of AI in games and simulations. Evolutionary design leverages these algorithms to create the innovative and optimized designs such as aerodynamic shapes for aircraft, architectural structure, and complex engineering system where the traditional design methods may fall short. These examples illustrate the broad applicability and effectiveness of evolutionary computation in driving the innovation and solving the intricate problems across various domains. So now the hybrid system in soft computing. Hybrid system in soft computing are advanced models that combine the multiple techniques such as fuzzy logic, neural network, genetic algorithm and evolutionary computation to leverage their complementary strengths and improve the overall performance. By integrating these methodologies, hybrid system can handle a broader range of problems with greater efficiency, adaptability and accuracy than any single approach alone. One notable example of a hybrid system is a neuro-fuzzy system, which combines the neural networks and fuzzy logic. In a neuro-fuzzy system, the learning capabilities of neural networks are used to fine-tune the fuzzy rules and membership function, enhancing the system's ability to handle the imprecise data and adapt to changing the environments. This synergy enables the system to learn from the data like a neural network while maintaining the interpretability and robustness of fuzzy logic. Applications of neuro-fuzzy system include the control system where they improve the performance of complex industrial processes and in decision making where they enhance the accuracy of diagnostic systems and financial forecasting models. So another example like genetic fuzzy system which merges the genetic algorithm with fuzzy logic. In a genetic fuzzy system, the genetic algorithm optimizes the structure and parameter of a fuzzy system such as the selection of fuzzy rules and membership function. This optimization enhances the system's ability to model the complex relationship and improve its decision-making capabilities. Application of genetic fuzzy system include the optimization problem in scheduling where they find the efficient solution by considering the multiple constant and preference, and in design where they create optimized engineering designs with improve the performance and reduce the cost. So this hybrid system demonstrates the power of combining the different soft computing techniques to create the more robust, adaptable and efficient solution. So highlighting the potential for innovation and advancement across the various fields. So thank you for joining us on this journey through the world of soft computing. We hope you found this exploration both insightful and inspiring. If you enjoyed this video, please give it a thumbs up, subscribe our channel for more tech content and share it with your friends. We would love to hear your thoughts and questions in the comments below. For more in-depth resources, check out the links in the description. See you in the next video.